So good morning, all of you. In the today's session, we are going to see one important concept, which is called as a efficiency. Now we are going to relate this concept of efficiency with the energy, and it is very much important in the engineering applications. So efficiency is a measure of how effectively an energy conversion or transfer process is accomplished. It quantifies the ratio of useful output to total input energy. In other words, it measures how well a system can convert one form of energy into another without wasting the energy. So the importance of this energy efficiency lies in the following engineering applications. So the first one is the optimization. So understanding efficiency helps engineers to optimize systems to minimize waste and maximize output. Also, in case of energy conservation, by improving efficiency, we can reduce overall energy consumption and decrease its environmental or the bad effect on the environment. Now, another important is the cost saving. Efficient systems often lead to lower operational cost by reducing the amount of energy input which is required. Now, there are certain misuse of this definition. The first can be a contextual definition. Efficiently can be defined differently depending on the context. So, if it is a thermal efficiency versus mechanical efficiency, and this can also lead to a misunderstanding, and if it is not properly clarified. There are some cases of misinterpretations. People confuse high efficiency with absolute performance or overlook other factors like cost effectiveness or environmental impact. Okay, so these things we have to keep in mind when we are dealing with the term of energy efficiency. In the coming sessions, I will clearly give you the distinction between what is meant by efficiency and what is meant by effectiveness by giving a proper example. We will now look the next concept is the definition of energy. Energy can be calculated by using the formula is given by desired output divided by required input multiplied by 100. This formula measures how effectively input energy is converted into useful output energy. It quantifies the proportion of input energy that is successfully transformed into the desired form, while any remaining portion is considered waste or lost. Now take an example of a light bulb efficiency. A light bulb converts electrical energy, which is input, into visible light, that is desired output. But some of its electrical energy is lost as heat, which is undesired output. The efficiency of the light bulb can be calculated by comparing the amount of visible light produced to the total electrical energy which is consumed. For instance, if a 100-watt incandescent bulb produces about 70 lumens per watt, and assuming it consumes all its power to produce both visible light and heat, we can calculate its efficiency based on how much useful light it emits compared to total power consumption. A resistance heater such as electric water heater are considered nearly 100% efficient because they convert almost all the electrical energy which is consumed into thermal energy. This means that virtually all electricity used by this heater is transformed into heat with minimal losses in form or like light or kinetic energy. Now here the question arises, why are they efficient? The high efficiency of resistance heater is from their direct conversion process. Unlike systems that involve multiple steps or conversions, such as generating electricity from fuel, a resistance heater directly converts or uses electrical current to produce high heat through resistance in conductors. Take a small example of electric water heaters. Electric water heaters are the common examples of this resistance heating. These devices use electric elements to heat water efficiently by converting electrical energy directly into thermal energy. The efficiency of these systems depend largely on how well they are insulated to prevent heat loss rather than the conversion process itself. However, while resistance heaters have high local efficiency, that is, converting electricity into heat, their overall efficiency can be lowered when considering the generation and transmission losses associated with the producing of this electricity. For instance, if most electricity is generated from fossil fuels with an average conversion efficiency around 30 to 40%, then only about 30 to 40% of the original fuel's energy ends up as a useful heat in our home. Now we will compare the efficiency of electric water heater and gas water heater. In case of conventional electric water heater, typically achieve an efficiency of about 90%. This means that approximately 10% of energy is lost as heat to the surrounding. Some well-insulated models can reach efficiency up to 94%, means minimizing the heat loss to the surrounding and maximizing the energy use. The electric water heaters are generally more efficient in converting electrical energy directly into thermal energy without the combustion losses. Now, in case of the gas water heaters, they actually have lower efficiency, typically around 55%, primarily due to combustion losses during the heating process. Despite their lower efficiency, gas water heaters often result in lower annual energy cost compared to electric models. This is because natural gas can be cheaper than electricity in many regions, offsetting the efficiency difference. There are certain practical considerations in choosing the energy systems. While efficiency is a crucial factor in selecting energy system, it is not the only consideration. Other practical factors play significant role in determining which energy system is most suitable for specific needs. So the first is the energy source availability. The choice between electricity and natural gas often depends on what resources are readily available at the location. For instance, areas with abundant sunlight might favor solar power over gas-based systems. Next is the initial investment versus long-term savings. Higher upfront costs can be offset by long-term savings. If an efficient system reduces operational expenses significantly. This balance requires careful financial analysis to ensure that initial investment yields return over time. Next important parameter is the environment. Renewable energy sources like solar and wind have lower environmental impacts compared to fossil fuels. Considering emissions and sustainability can be critical for organizations aiming to reduce their carbon footprints. Next is the system efficiency versus cost. Higher efficiency do not always translate into lower cost due to differences in the technology prices or operational complexities. For example, electric water heaters are more efficient than gas heaters. They might have higher operating costs depending on the local electricity prices. Next is the location-specific factors such as the climatic conditions. Example, the sunny regions suit the solar panels, and the geographical features, that is, windy areas suit wind turbines, must be considered when choosing an energy system. And finally, the most important factors, that is the budget constraints and incentives. The budget limitations can dictate which systems are feasible initially. Local incentives or the subsidies may also influence the decisions by making certain options more economically viable. The efficiency of combustion-based system is directly related to the heating value of fuel, which is used. This efficiency measures how effectively a system converts chemical energy from fuel into usable heat. The formula for the combustion efficiency is given as the amount of heat released during the combustion divided by the heating value of fuel, and this multiplied by 100. So what is meant by heating values? There are two types of heating value. The first one is the higher heating value, and the next is the lower heating value. The higher heating value includes the heat released when the water vapor produced during the combustion condenses back into liquid water, and it is useful in applications where this latent heat can be recovered. The lower heating value excludes the heat from condensing water vapors, and it is relevant in the systems where this latent heat is lost to the environment. Take a small example of gasoline heating value. The higher heating value for gasoline is about 47,300 kilojoules per kg, and the lower heating value for the gasoline is 44,000 kilojoules per kg. What is gasoline? It is nothing but our petrol. Now here, this difference between the higher heating value and the lower heating value is due to the energy potential recovered or lost during or depending whether the water vapor condensation occurs within or outside the systems. Now, there are certain bases for calculating the efficiency. So, for example, we can take an example of cars or the jet engines. This typically uses a lower heating value because they operate under certain conditions where water vapor do not condense within them. Thus, its latent heat cannot be utilized. And in case of furnaces, they often use higher heating value since these systems are designed to capture as much energy as possible from both the sensible and latent heat through the proper insulation and design features that allow the moisture recovery. Now we will see the power plant and the lighting efficiency difference. So what is power plant? The power plant is where we generate electricity. Okay, this power plant can be thermal power plants, okay, which uses coal, natural gas, or the nuclear form of energy. Okay, and there are also certain power plants which uses diesel engines, petrol engines to produce electricity that we call as a genset. In this case, if you want to know what is the efficiency range of this power plants, so for example, in case of a petrol engine genset, a generator which uses petrol as a fuel is having an efficiency around 26 to 30%. If a generator is using diesel as a fuel, it is having the efficiency in a range of 34 to 40%. So you can ask the questions, why the diesel engines are having the more efficiency as compared to petrol engines? The answer is because the diesel engines uses a higher compression ratio as compared to petrol engines. So why we cannot use the high compression ratios in case of petrol engines? That we cannot do because there is the problem of knocking or detonation in case of the petrol engines if we use the higher compression ratio. Now coming on to the large power plants such as the power plants which are using coal as a form of fossil fuel to generate electricity, or we can use the natural gas. So you must be knowing the nuclear power plant which is there in Tarapur in Mumbai, and there is a natural gas power plant which is in the Uran in Maharashtra. Okay, so in the Uran you can see there is a gas turbine power plant which uses the natural gas as a fuel for generating the electricity. Now in case of these large power plants, this achieve the efficiency between 40 to 60%. Not beyond that. Now, the formula that we are using to calculate this overall efficiency is the combustion efficiency multiplied by the thermal efficiency multiplied by the generator efficiency. Now, this formula highlights that the overall efficiency depends on how well each stage of energy conversion performs. For example, the combustion efficiency relates to how effectively the fuel is burned. Thermal efficiency involves converting heat into mechanical energy. And the generator efficiency pertains to converting mechanical energy into electrical energy. Now, coming on to the lighting efficiency, means the equipments which we use in our homes for the lighting, such as the bulbs. Okay, in the bulbs there are so many categories such as the regular incandescent bulb, the fluorescent bulb, the LED bulb, the high intensity discharge lamps. Okay, so these are the different bulbs or the lighting devices which we use in our homes or at any other locations as per our application. Now, if we want to know what is their lighting efficiency, what is lighting efficiency means the light they give to us and the electricity which they utilize for giving that light. In case of this incandescent bulb, they are only 10% efficient, which indicates most energy is lost as heat rather than visible light. The fluorescent bulbs, which are about 4 times more efficient as compared to this incandescent bulb, due to their ability to convert more electric energy into visible light. Okay. Now the next category is the LEDs and high intensity discharge bulbs. So this offers the highest lighting efficiency among the common options, converting a large portion of the input energy or the input electrical energy directly into visible light. Okay. Now there is one term which is known as the efficacy. Now, what is efficacy? Efficacy is the term which we are using in case of this lightnings. Now, efficacy is measured in lumens per watt, indicating how much light output is achieved per unit of electrical power consumes. So here the unit we can see it is lumens per watt, means at the numerator it is the amount of light in lumens, and at the denominator there is the electrical energy in watts. So by using this terminology we get what is meant by efficacy. Cooking appliances converts electrical or chemical energy into heat, which is then used to cook food. The efficiency of these appliances is determined by the ratio of useful energy transfer to the food versus the total energy input. Now, there are different types of cooking appliances, such as the induction cooktops, traditional electric stoves, and gas stoves. Now, we will see their efficiency one by one. So, in case of this induction cooktops, these are generally more efficient than the traditional electric or gas stoves. The induction cooking directly heats cookware using electromagnetic fields, reducing the heat loss compared to conventional methods, where the heat must travel through air or water. In case of traditional electric stoves, these are less efficient due to significant heat loss during the transfer of heat from the coil to the cookware. In case of these gas stoves, these are also less efficient compared to induction because some energy is lost as radiant heat and in the combustion process. So here the factors which influence the efficiency is the heat transfer mechanism and the energy input versus its output. So in case of this heat transfer mechanism, direct heating methods like induction tends to be more efficient. Now, in case of this energy input and the output what we are getting, if you have the closer the output in form of heat matches the input, what is the energy consumes, the higher is the efficiency. Therefore, the more the output which is in form of heat and the more the input which is in form of heat, we can get the maximum efficiency in these devices. Now here, we all know there are certain mechanical equipments, devices, and when we are dealing with these mechanical equipments and devices, we encounter the term as the mechanical efficiency. The mechanical efficiency is defined as the ratio of useful mechanical output to the mechanical energy input. It measures how effectively a system converts input energy into productive work. Examples of mechanical device, as you all know, what is ropes, chain, gears. Okay, these are the mechanical devices which are used for transmitting the power. And in these devices, we often come into the term that is mechanical efficiency. And this term is calculated by using the formula which is given by useful work output divided by work input and multiplied by 100. Okay. Now here, there are certain factors which affects this mechanical efficiency. So the first is the frictional losses. The friction between the moving parts reduces the efficiency by converting some of the mechanical energy into heat rather than the useful work. Now, therefore, in the mechanical devices, we want to keep this friction as low as possible. Next is the mechanical wear and tear. Over the time, wear and tear on the components can increase the friction and can reduce the overall system performance. And finally is the lubrication quality. As we all know, in order to reduce the friction and the mechanical wear and tear, we use the lubricants between the mating parts. And if there is a proper lubrication, it can minimize the friction losses by reducing the contact between the moving parts and thus maintaining the higher efficiency over the time. Pump efficiency is defined as the ratio of hydraulic power output to mechanical power input. It measures how effectively a pump converts the mechanical energy it receives into useful hydraulic energy. The formula for the pump efficiency is given by hydraulic power output divided by mechanical power input multiplied by 100. Now, the factors which affects this pump efficiency includes the pump design, the fluid properties, and the operating conditions. Now, in case of this pump design, the design which includes the impeller shape and size affects its ability to efficiently transfer energy. Next is the fluid properties. The characteristics like viscosity and density influence how easily the fluid can be pumped. And the next is the operating conditions. The conditions such as the flow rates, pressure head, and speed impact how efficiently a pump operates. Turbine efficiency is defined as the ratio of the work output from the turbine to the energy available in the fluid. It measures how effectively a turbine converts kinetic or potential energy from the fluid, such as steam, gas, or water, into mechanical work. The efficiency formula for the turbine is given as the shaft work output energy divided by the energy which is available in the fluid, whole multiplied by 100. Now there are certain factors, okay, or there are certain types of these turbines. These are categorized as per the fluid which is used in this turbine. The first one is the steam turbines. They are using steam and they are used in the power plants where high pressure steam expands through the nozzle to drive turbines. They are efficient at converting the thermal energy into mechanical work. In case of these gas turbines, they are often used in the jet engines and some power generation systems. They operate by expanding the hot gases produced during the combustion through the turbines. Next are the hydraulic or the water turbines. They are primarily used in the hydroelectric power plants. They convert the potential energy which is stored in water behind the dams into the electrical power by driving the generators connected to the turbines. The generator efficiency refers to the effectiveness of a generator in converting mechanical energy into electrical energy. It measures how well the system transforms input mechanical power into useful electrical output. The formula for the generator efficiency is given by electrical power output divided by mechanical power input multiplied by 100. The factors which affects the generator efficiency are the electrical resistance, magnetic losses, and cooling effectiveness. In case of this electrical resistance, these are the losses due to resistance in conductors which reduce efficiency by converting some energy into heat rather than useful electrical energy. The magnetic losses are the losses due to hysteresis and eddy current losses in the magnetic material which are used within the generators. And finally, there are the cooling effectiveness, means there should be a proper cooling to which helps to maintain the optimum operating conditions by reducing the thermal stress on the components, thus improving the overall efficiency. Okay.